All right, so question 10, as we go through, I'm just going to put it down the bottom. So I've got questions 6 to 8. Then I'm just going to keep going from question 10. Again, if you're talking, I need you to stop. You can keep going with your worksheet. Don't move to the next page, so you can go to the middle and the right-hand side. So the question says, to find the density of a solid or liquid, we divide its mass by its volume, i.e. density D equals mass M over volume V. So the only really important bit of information there is that formula. So that's the first bit we would highlight. We're going to be using that formula. Whatever formula they give you, we need to know how to do what that is. Then the next part says, if the mass is in kilograms and the volume in cubic meters, the density will be kilograms per cubic meters. So this sentence is just actually working out what the measurement would be. So it's just saying whatever measurements you've got for the two things you're dividing, that's what becomes in your answer for density. If the mass is in grams and the volume in cubic centimeters, the density will be grams per cubic centimeters, etc. It says find the density of aluminium if 100 cubic centimeters has a mass of 270 grams. So for A, the information we've been given is 100 cubic centimeters and 270 grams. So to use this formula, it's saying find the density. We don't know what density is. So we need to know which one's the mass and which one's the volume. How do we know which one's the mass and which one's volume? It's in the question, it says mass is 270 grams, but also volume. If you're looking at volume, volume will always have to the power of 3. Okay, so we've got to go, okay, that means this one's volume, this one's mass. Once you've defined the variables in the equation, it's actually quite easy because we just have to sub them into the formula. So D equals 270 over 100. So D equals 2.7, and we use the same measurements. It's the top and over the bottom. So 2.7 grams per cubic centimetre. So it goes in the same order. Any questions about that? The next three are the same. So it's exactly the same. You've just got to pick out your different numbers. I'm not actually going to go through them because they are exactly the same. For D, change my computer. For D, it gets a little bit confusing, and D is where most people then fell down in this question, okay? And it says, the density of seawater increases with depth due to the pressure of the water above. Find the density of seawater in grams per cubic centimetre. So it's saying seawater, if it's at the top, has a certain density. In the middle, it changes. At the bottom, it changes, and it increases over time. That's the bit which confuses people. But what it's actually saying is find the density of seawater. So you know how the other ones had like aluminium, lead, diamond? It's seawater for all of them. It's just that the density changes at different levels. So you don't have to do anything with the 1,000 metres. You don't have to do anything with the 10,000 metres. It's just giving you some information about where that seawater is coming from, okay, or where it's being measured. So for the first one, it's actually exactly the same as A, B and C. We're just looking at seawater. The mass is 5.14 grams, 141 grams is the mass, and the volume is 5 cubic centimetres. So we've got our formula, all we do is sub it in. So we've got our formula of 5.141, which is our mass, over our volume, which is 5. And then we find our answer, and it will be grams per cubic centimetre. You just put that in your calculator. Haven't got my calculator on me at the moment, so if someone needs to find it, or we'll just leave it like that. It's fine. Does everybody understand that? So it's exactly the same as A, B, and C. When you get to E, it's the same. It's still salt water. This time it's at a depth of 1,000 metres. But what you'll notice is at that depth, the mass changes. So therefore, the density is going to change. You don't need to do anything about the 1,000, but the information they've told you is that the mass is 5.164 and the volume is 5. So the story told you that as salt water is tested at different depths, the density is going to change. The reason that density is going to change is because this mass changes here. And so all we've got to do is do exactly the same thing. Sub in those numbers. We defined our variables, sub in those numbers to find out what the density is. So this time density equals 5.164 over 5, and you'll find your answer again. For F, we do exactly the same thing, but with the new mass. Any questions about question 10? So really where it is confusing is just about working out which bit of information they've given you need to use. But if you can think about it in terms of the formula, what does the formula need? What does the formula include? As long as you can define all those and you've got one to look for, it shouldn't be very hard. But sometimes they trick you, and that question tricked me too. All right, question 11. Any questions on question 10, sorry? Okay, question 11. Question 11 says, if you deposit P dollars in a bank account that earns interest in X% per annum, compounded annually, the amount in the account after T years will be A dollars, where a big formula, okay? Now, this is really important that you know how to do because finance is a major topic in this course. I think we spent about 5 weeks on it, and it is a major topic in year 12. It's a 1/6 of the course is finance for next year. So you need to know how to use it. Now, I love finance because I think that that is the one maths topic which is actually a real application to you guys. You need to know when you're putting money in the bank what's actually going to happen to it. You need to know what's going to happen when you get a car loan. You need to know what's going to happen when you buy a house and all those sorts of things, credit cards and things. So this is really important, but we will try and make it applicable to you guys so you can actually use it. However, not when we're doing a homework question, when we actually do the topic. So it tells us we've got this formula. So again, I'm going to write the formula. A equals P bracket 1 plus X over 100 to the power of T. So we need to define the variables. We need to actually work out what these things mean. And if we can work out what these things mean in the real world, it's actually a lot easier to understand in our heads as well. So it says, if you deposit P dollars in a bank account, so we've got P, what does P represent? If you deposit P dollars in a bank account, the amount you deposit, so it's called the deposit, really, and it's in dollars. It's also called the principal, which is why that P is there. If you deposit P dollars, so our deposit, what's a deposit? Money you put in the bank, yeah? So the deposit is money you put in the bank. That earns interest at X% per annum. So what's X represent? The percentage of interest. What's interest mean? How much? Yeah, so if you give money to the bank and you put money there to sit there, the bank gives you interest. It gives you extra money. It's like saying, it's like them saying, thank you. Thank you. You've given us your money, because they can then use your money, invest it, do things, whatever. As long as they can give it back to you later, it's okay. But they give you a little bit of extra, which is called interest. When you borrow money from the bank, they charge you extra, which is that little interest, because you're then saying thank you to them for giving you the money. Yeah? So interest as a percentage is X. Compounded annually, the amount in the account after T years. So what does T represent? Time in years. Because it says T years, okay? If it said T months, then it will be months. And will be A dollars. So A dollars, A is something in dollars. It's that sort of final amount. It's your final amount, how much you're going to actually make over time. So we've now defined those 4 things. So we know what it's saying. So then when we get to our question, part A, we can be able to sub them in. So A says $300 is deposited at 10% per annum compounded annually, which is that year thing, but that's all right, we can talk about that another time, after 5 years. So what's the $300? What letter does it represent? Say it again, ladder, Harry? No, Kibby? P, good. What's the 10% represent? X. What's the 5 years represent? T. Once you've got that and you've got a formula, all we have to then do is write out our formula. A equals 300, 1 plus 10 over 100 to the power of 5. I think where most people went wrong with this question is they actually put like 1, or they put it different. They didn't notice that in the question it says after 5 years. And that's where most people made mistakes. And we sub that in, and someone got an answer. And that's, I think it's like $483, but I'm not sure. 400, and do you have any cents? 50? 15. 15 cents. Now, when we come to money, we always round to 2 decimal places, so to a single cent. So think about if you go to Woolies, something can be charged $9.98, even though you pay a different amount if you're paying in cash. If it went on your credit card, it would still be $9.98. Okay, so anything money you need to know goes to 2 decimal places. And in your WACE ATAR exams, if you round differently, if you round money to not to 2 decimal places, you're going to lose a mark every single page, which says money. So we're going to be doing that for you guys. We're going to be doing that to you guys with your assessments this year to get you used to that. So you need to be aware, anytime you see money, to a single cent, 2 decimal places. But we'll practice, okay? I'm not going to do B and C unless someone wants me to. Does anyone want me to do one of the other ones? All right, then question 12. I think where most people go wrong with question 12, it's just about actually noticing the measurements. So most people got question A right, 12A right, and then got B and C wrong because they didn't read the question correctly. So question 12 says that there is a pendulum of a clock shown on the right performs 1 cycle as it swings from A to B and back to A again. The time taken for a pendulum of length L, so L means length L, meters. So it specifically tells you that it has to be in meters because it says length L meters. To perform 1 cycle is T seconds. So T is a cycle, is time in seconds. All right? Where T equals 2 pi to the square root of L over 9.8. So again, this is about using your calculator correctly. So the first one, it tells us if the pendulum is of a length 1.15 meters. So we know L is 1.15. So all that we sub in is T equals 2 pi to the square root of 1.15 over 9.8, and we get our answer. So that's for A. For B, where people went wrong, was that it says 40 centimetres. Because it says centimetres and yet L is in metres, you need to be able to convert that centimetres to metres. So how many metres is 40 centimetres? 0.4 metres. So that's something you're expected to know. Once we've got that, it's actually quite easy again. So T equals 2 pi square root of 0.4 over 9.8, and you'd get your answer. Okay, so it's about, C is exactly the same. It's just about reading it.